Well, first, I would like to thank you for the opportunity to come over here and talk to an amazing group of people here at IBM. So, to the talk here today, I'm going to talk about technology, exponential technology, and where we're headed, population, the intersections. I'll talk about maybe some of the main technologies that are going to be mainstream, and how do we prepare for that. And then I'll talk about different aspects of innovation. And the most important part of the presentation is my own personal perspectives throughout 20 years, what I've learned. How do you make organizations more creative, more innovative, and more effective at what they do, essentially? So if we look at the population of the Earth, for the last 200,000 years, the evolution of the modern humans, until almost 1800, you'll see that the whole population of the Earth was less than 1 billion people. Now, in the span of 200 years, we went from less than 1 billion people to about 7.5. And if we keep extrapolating, we're going to reach, by 2050, about 10 billion people in Earth. Now, the trend is, it's kind of interesting, because at the same time, we have exponential growth in technologies. So if you look at the chart by Ray Kurzweil here, we're supposed to be, in 2030s, maybe the computational power of a human brain will be able to be in a system. And then if you keep going and moving along, you'll have the computational power of all of humanity, all the population of the Earth. So imagine in the future, in the distant future, you'll have a power of a phone, for example, of a smartphone that has so much capability. We're talking about billions of people, power in one single machine. Imagine the possibilities that we'll create. I think the possibilities are endless. It's amazing. We're also seeing an amazing increase in robotics. Robotics are becoming more popular, increasing more and more, and it's going to be about $70 billion market by the year 2025. Now, robotics by itself, it's good, it's effective, but the power comes in when you couple robotics and artificial intelligence together. That's when the magic happens. So if you keep going with that trend, and I think in about 100 years, it will be very difficult for a person, for humans, to distinguish between an actual humanoid robot and an actual human. We're going to get there. It's the time, maybe it's more or less, but eventually we're going to get there. So how is that going to look? What's going to happen? We have an exponential increase in population, and we have exponential increase in technology. So there's going to be a phased approach here. Initially, people are, well, every time we create technologies, they always create jobs. So jobs are created by the time we create technologies. Now, this is going to be a little bit different. And by the way, this is a very controversial topic. So if you talk to scientists, researchers, experts, almost 50-50, they will think it will have a positive effect, it will create more jobs. And the 50 are very concerned. They say, okay, I think this is going to be tremendous impact on human race, population, jobs, economies, and so on. And so imagine, for example, we're talking about creating a new species here. So we're having humanoid robots that will almost behave like humans with the intelligence power of billions of people. So imagine what power can we do that? How can people compete with such elements? Obviously, there's always going to be jobs that humans can do. But if you look at the progression, it will be transition. So instead of certain jobs will be required 20 people to do the job, maybe it will start tailoring that down. Maybe we'll need 10 in certain time. As we keep advancing, we need less and less and less people to do the job. We've seen that in mission control in the 70s with the Apollo program. We have hundreds of people in the back rooms reviewing things and working with the front mission control. And now, and we had two phases. We had the shuttle phase, and now we're having the future phase. And the more we move forward, the less people we need. It's much, much less, because computational power and systems can do most of the stuff for you. You don't need as much. So the concern is, so what's going to happen then? You know, we have less needs for humans, and we have significantly more humans. So all I'm saying here is, I don't know, nobody knows what's going to happen in the future, but something we know for sure that's going to have significant impact. And these are things we need to start working on it and think and strategize and think about solutions, how it's going to impact us, and how can we adapt and work on it way in advance. So something else also I've noticed is a lot of companies and academia, for example, academia, they develop a lot of intellectual properties, a lot of technologies. and then there's no use for it, or they don't have specific customers. And I see that in companies as well. They develop a bunch of IP, a bunch of technologies, but they're not aligned with that strategy of the business, so they end up being shelved and not used. So the key is you need to have a strategic implementation where when you develop technologies, develop anything, it has to have a line. Whenever you develop it, there's a line that's going to come out of it. It's going to create jobs, it's going to create new technologies, and have clear path. Not only create it and shelf it, because that's going to be wasted resources, essentially. And all of us struggle with this problem in every single industry. And like I said, academia do a lot. You go to technology transfer offices, they're filled with patents that nobody's interested in. So that's something I think we can definitely, all of us as a community, work on and become more effective. Another thing is when we strategize about the future, we always think about today. So when we're trying to see what's going to happen in the next 15, 20 years, we always anchor ourselves in today. It's very difficult for us to forecast and imagine what's going to look like. And that's sometimes it keeps us grounded and prevents us from being creative and thinking about what are the technologies going to be looking like in the future. So let's talk quickly about why is NASA interested in innovation, for example. And after we retired the space shuttle was essentially meant for developing and building the space station. That's it. That's all it was. So we have built the space station, and the space station essentially is a lab. When we go, our goal is obviously to go beyond the solar system. It's not only stopping at the space station. There are so many things we don't understand about the human body, for example. Muscles, they react very differently in the microgravity environment, radiation, bones. So there are so many things we need to understand before we commit to sending humans to leave the safety of Earth and spend years outside of our solar system or outside of our planet here. So a lot of these challenges, the further you go, the more complicated it gets. I mean, the Mars mission is very, very complex. It has so many things we don't understand in terms of, first of all, how to deal with cosmic radiation when you leave the Earth. Propulsion, we need to develop advanced propulsion systems to get us there. Even simple as psychology. I mean, how do you put people in small space? How do you deal with each other? You know, we need to learn about how to deal with these problems. Also, so the mission right now, we're talking about Mars. There's some thoughts about Moon, or there were some thoughts about going to an asteroid. Everything is gearing toward a mission to Mars right now. And that's something that's going to require international efforts, and definitely there's going to be a lot of creativity, because that requires a lot of money, a lot of financial resources, a lot of technologies, tremendous challenges. And we need to work on it and create very innovative solutions to be able to for us to achieve these goals. So if you look also at the role of the government at NASA, how they contributed significantly, initially early on in the century, we're doing a lot of research on aeronautics. And aeronautics basically got developed into companies, commercial companies, taking advantage on leveraging on it. And we have Boeing, we have Lockheed, we have Airbus, and so on. We're able to use the resources created and be able to create economies. And it's in the trillions of dollars with significant amount of employments all over the world. The same thing that's happening now is new space. So this new space was not been able to be possible without the contributions from the space agents, from NASA, for example. We created the technology, the know-how, everything else, and now we're moving out of the low Earth orbit, emphasizing on the deep space exploration and enabling the economies, industries, private companies to come into that space, that gap that we're leaving, and create some economies out of that. And like I said, it's due to all the technologies that were created. Sometimes people say, well, you know, look at certain companies, without mentioning any names. Look how they do it much cheaper, they're much more effective, and obviously there's an element of truth. If you're a private company, there is more element and wiggle room, and to become more creative, they have less restrictions. But without all the investments that the governments put into that would have been impossible to do. So the technology is developed, the know-how is there, it becomes much easier for them to do these kind of things. So you can look at it different ways. So what are the main technologies that we're seeing as becoming mainstream in the future? So obviously big data is something very, very important, Internet of Things. But all these don't mean much without having a system that actually can go through the big data and making something meaningful out of it. So we look at, for example, so we have so much information coming from satellites, from the space shuttle, companies like oil and gas industry. So many industries, they have so many sensors and so much data, and sometimes just don't know what to do with it. So the key is how to develop systems that actually can decipher and connect dots and in ways that nobody else can do that. And in the medical field as well, we always talk about the medical field. We have hundreds of thousands, millions of records. And I'm confident if we use a system that's smart enough, it will be able to use and find trends that humans will not be able to find before. And that will result in significant predictions of disease progression and cures, and it will have a big impact. So it's very, very important elements, the big data, Internet of Things, and most importantly, the algorithms, and how to put all that stuff together. So driverless cars, that is definitely going to have a huge impact in the future. And for us at NASA, for example, we're interested in this because, as you know, as the further we go from Earth, the signal takes much longer to reach whatever vehicles we're having. So if we talk, for example, Mars, it could take up to 20 minutes each way signal to get there and come back. And if you have a vehicle that's driving or you're controlling it from Earth, you don't know what's going to happen if it's approaching a hazard. So we're very interested in autonomous, smart system that actually can see the terrain and adapt and be able to do everything without external human interference. And if you look at it, how it's going to happen here, so it's going to, the goal is achieving 0 accidents. So the accidents will go down substantially. We're going to be able to increase productivity. Imagine how much time you spend just driving behind the car, just completely wasted time. So all that stuff will be increasing productivity substantially. There's one time I gave a talk on that. It's a whole hour discussion about driverless cars and so on. But also look at what's the impact on businesses. So that means car manufacturers will never be able to produce or the amount of cars because there is no need for it. In the States, for example, every household has maybe 2 or 3 cars. There is absolutely no point in having that. A car will take every person to their destination and pick them up. And if you think about it, you come in the morning, you put your car, you park your car outside, and you only pick it up maybe to do an errand or pick it up at the end of the day. So most of the time it's parked there. So that means car manufacturers will significantly reduce the output. If you look at insurance companies, there won't be as many cars to insure. And even if they become 100% safe, then insurance becomes less important as well. Oil and gas companies, there won't be as many resources to sell because there's not as many cars available. and we keep going that way. So I think it's very important for people in that industry, for example, to start strategizing. He said, this is coming, and it's going to be a transitional plan, obviously. It's not going to be immediately from nothing to driverless cars. It's going to be a transition. We're going to have car-assisted systems, which we're having a lot right now. And then eventually, we're going to get into a phase that it's common just to have a completely driverless car. And the more we have, the more we refine the algorithms, because the algorithms is based on data. So the more data we have, the better the algorithms are refined, and so on. But also, it's important to notice that it has risks. So these cars leverage a lot on laser systems, on equipment, and we don't know what the long-term implications on humans are. So these are things that need to be investigated. And the most important, I believe, is cybersecurity. So you need to have a car that's actually very difficult for people to hack. Otherwise, imagine you're driving, the car is driving you, taking you from one place, and immediately you lose control and somebody else veers it. So these are definitely challenges are needed to be implemented and investigated before we become comfortable with all these technologies. Miniaturization, you guys know a lot about this stuff as well. Look at the computational power in the 50s and what we have right now. So take that and move forward 50 years. I mean, you can imagine what we're talking about. And for the space, actually, it has tremendous contribution. So the previous satellites, it used to cost hundreds of millions of dollars. And the technology at that time was growing slower, so it was okay. But now, every few years, we have a new technology. So what we've done is concentrating more on micro and CubeSats. So CubeSats, typically, because it's in low Earth orbit, they don't last very long, typically on average about a year. But that's good, because the cost is extremely cheap, and then you can have an opportunity to replenish them with the state-of-the-art technology. So that gives you always the best technology available for a decent price compared to satellites that used to last 10, 15, 20, 30 years and they cost you hundreds of millions of dollars. So by this technology becoming smaller and more efficient, look at the change in the models between the old times and the new times and keep going forward with that. Augmented reality is going to have implementations in every single aspect of our lives as well. Virtual reality. Sometimes we go to the labs and look at simulations of the space station and so on, different aspects. It's very difficult to tell, is it real or is it not real? Sometimes your brain gets tricked into it and becomes very, very complex issue. So imagine how that technology can look in the future. It's just amazing. Medical field obviously is one. We're interested in using them for training or for maintenance. So astronauts can put the glasses on when they're working on certain missions, and mission control can see exactly what they're working on and can give them instructions on the screen of the glasses, and can help tremendously in being able to solve problems. So it has an applicability in so many aspects. Autonomous flying vehicles, it's also something that's coming up a lot, and we're talking about deliveries, real-time deliveries, and things like that. But so the key is not only what technologies are available, but what services will be needed, because these are base technologies, but with each technology there's services industry that will come. Like the internet was a technology, but look at what happened. It was the base. From that came so tens of thousands, hundreds of thousands of companies that leverage on that technology as services. So we need to, right now we're starting to see main things that are happening, but how can we develop things that will work in that space? 3D manufacturing, it's a tremendous thing. Obviously for us, when we go to a different planet or far from Earth, we can't take all the resources with us. We can't take enough spares. So it becomes very problematic sometimes if something fails. So for us, it's very important to develop resources that can actually in situ manufacturing whenever we're going. And in Mars, we're looking at using the regolith, the sand from Mars, as a feedstock for these to create tools, manufacturing, building things. And also, when you're having critical sensitive equipment, the launch environment is a very severe environment. So it's very difficult sometimes to build intricate, very small components because it's going to be difficult to maintain them intact when you're launching. So it will be an opportunity to build very detailed, sensitive, small equipment on orbit, and we'll be able to be much more effective than the ones we have right now. That's something that's going to have, again, applicability in manufacturing, in medical. We're talking about having 3D printing organs. In the food industry, in the clothing industry, it has applicability in every single place, and absolutely it's going to be mainstream. Again, we can't just base everything on the little 3D manufacturing systems we have right now, because that's expanding far, far, far from where we have it right now. And again, cybersecurity, I believe it's a main element keeping everything together, because without cybersecurity, most of these technologies won't be effective, and they won't have a good place going there. So I'm just going to give quick examples about disruptive technologies. One of the things I would like to mention is Zara. How many people are familiar with the company Zara? Yeah, okay. So Zara is an interesting company. When they came into the market, there was serious doubts that will be successful, because apparel business is very, very competitive. It's not an easy one to get to. So what these people did differently is typically when you're manufacturing something on a conventional clothing industry, it takes about a year from the time you start designing until it hits the shelves. So Zara did two things. So the first thing is they expedited the production process from the design to the shelves. They did the whole thing in 2 weeks. So in 2 weeks, you'll have a designer working on it until it hits the shelves in 2 weeks. They create scarcity. So if you go to the stores, you only have very limited amount of stock. And once that's finished, they never do it again. It's only one-time deal. So it creates a sense of scarcity, which creates value. And the good thing about they do is the managers of the stores, sometimes they're walking around with their laptops or with their tablets or notes and talking to customers. So what do you think about this? What do you like about this shirt? What don't you like about it? They create a database of information based on the customer needs, and they send it, and if they see trends that certain number of people are interested in certain designs, 2 weeks later you have a new design based on that. So and they keep adapting and modifying and getting the customers' needs, and I think they have about 2,000 stores right now. Very, very popular store, just by thinking creatively and out of the box. Netflix is an amazing example. And that's an amazing example of actually changing business models. Sometimes you find one, you stick to it, and it's not good enough. So when they started, at that time it was Blockbuster Video, and it was, you had to go to a store, you have to rent a movie, and there was a lot of complaints about late charges, because sometimes people are busy, they're not, don't have time to go and return the videos. So it was very problematic. So Netflix was thinking into it, but they couldn't do much because sending these big VHS was very costly. So they waited until technology became effective and used DVD. DVD much cheaper to send, it's faster. So they developed a brilliant distribution scheme in different cities, and in one day you'll be able to get your DVD. And also change the model from just renting one to a subscription-based model. So people pay the subscription for the month, and you can rent as many as possible as long as you return it, and depending what bracket you're subscribing to. But then, so it became very successful, and they offered to sell themselves to Blockbuster. Blockbuster didn't see the value, and they passed on it, and we know what happened with Blockbuster. But again, they weren't satisfied with that. They said, okay, we need to keep changing. And when internet became fast enough, the broadband became fast, then they started streaming the movie. So people become impatient, right? I mean, the older the more technology we have, we want things faster, more efficient, and you're just not gonna order something and wait for 2 or 3 days to get a movie to watch it. So they developed an excellent library of movies that you can stream immediately. And because technology was available there, then they were able to implement it, and that's how they changed from DVD shipping into immediately watching a movie and by streaming. But then that wasn't enough. They saw a need that, that's a possibility, a place where a lot of competitors come in, and they might have an impact on the business model. So now what they're doing, they switched one more time from streaming business into a production business. It's a production company now. They have so much content, and they recently won an Oscar, actually. So that's how good they're becoming. So you can see the progression, and that's, I think, what made them very successful. You can't just find one single business model, stick with it. You have to adapt. You have to keep innovating and moving. Otherwise, there is always space for people to come in and start competing and take a big chunk of your business. If you look at smartphones, look at how many industries it disrupted. The camera, the GPS, the radio, the music, the gaming. So you're having so many industries into one single machine now. So there was substantial disruption to the profits of a lot of these industries, and some of the companies obviously went out of business because of the technology available. So the thing is, a lot of these technologies start up small in somebody's garage, and the key is, how do you scout? How do you find what technologies are being developed and designed and worked on, and start looking into them, adapting them early on before they become common, or before they become a threat to the company. And it's not difficult to find these things. There's always, you can have dialogue with venture capitalists. They know a lot about that stuff, because obviously small companies need funding to produce what they're doing. So if you find out, it's always better to be plugged into these small communities and find out what they're producing, and if it's aligned, if you have the vision to find what they're being produced and how you can fit it into your technology or your business model to improve your performance, it's always an advantage. So people sometimes ask, well, are people creative? Are they born creative, or is it something that you learn? And I found actually it's both. Obviously some people are more creative than others, but also you can augment and emphasize on these attributes to become more effective in design and creative and innovation. You can read books. You can immerse yourself in a culture that's innovative. You can read papers. There's so many things that you can work and use to improve your creativity, your out-of-the-box thinking. Definitely, there's definitely ways to do that. I'm going to give you just a couple of examples about how some creative ideas by some people. So there were some cities in Europe that were having problems with posters, and some of these buildings, they were antique buildings, like very ancient. They were very nice, and they're being ruined by putting so many posters about parties, about concerts, and so on. So, and they tried finding them and all that stuff, but nothing seemed to work definitely. So one of the people in the city hall came up with the idea, said, well, what if we come to these posters and we put a stamp saying concert canceled or date change? And they started seeing that there's a lot of people had started having impact on what they were doing, and they worked out a deal with the city that, okay, let's work together and find a place where these things can be shown, and that helped. So they were able to solve a big problem by just thinking creatively for a little bit. Another example is a small town that were having significant issues with speeding cars, and they put fines, and still people were speeding. So one of the guys thought about, say, what if we create a new business thing? So 30% of the proceeds from the speeding tickets will go to the cars that are not speeding. So they had cameras capturing every single car plate, and they recorded it. And the cars that were speeding, obviously they were fined, they were sent citations. And the cars that were not speeding were being put in a pool, and then they put 30% and distributed amongst these people that were not speeding. So by creating this incentive, I mean, it's obviously became great. I'm just going to stick the speed limit and probably get a check at the end of the month. So, and it was a good business model because they're still making money. They're still making 70% of the profits. But 30% were able to reduce the speeding tickets substantially. Another example in Holland, actually. This is a company in Holland that these are very sophisticated bikes that had a lot of electronics and expensive bikes. And they were noticing that the shipping companies were not paying attention. They put fragile and everything, but they didn't pay attention. They kept, big number of these bikes kept getting damaged. So one of the people there said, what if we package it as if it was a TV? So they did the package, assuming it was a TV, not a bike, and then they noticed there was a 70 to 80% less damage to the bikes by doing something simple as that, right? So sometimes it just takes this small idea like this. And by the way, the more you get exposed to these ideas, the more you work with innovative and creative people, these ideas will come more and more to you. It becomes more common to think that way. It's a train of thought that you start developing as you move. So biomimicry, there is a lot of innovation that's derived from nature, actually. We don't have to go far. Let me see here, next chart. So this is a lotus plant. A few years ago, I went to Japan with a professor, and we went to a lotus plant, and we noticed that water never sticks to the leaves. It's kind of fascinating how it works. So, and he told me an interesting story. He said, Japanese scientists took these leaves, they did the macro-analysis of it, and simulated the structure of the leaves into yogurt leads. And because, if you notice, every time you open yogurt, there's something stuck into it, so it becomes kind of... So they developed this, and now that problem completely went away. But just by something as simple as possible, as looking at the leaf in a field. Also, this is another example of underwater turbines. So turbines, they use underwater current to produce energy. And then they notice if they use ridges like these, derived like the same thing as whales, the efficiency became much, much higher. So they took that analysis and they implemented it into actual design, and they got significantly less drag and more efficiency in the turbine that we're having. Let me give you some cross-industry innovation examples, how industries working together and so on. So in Africa, some of the African countries were buying incubators. And they were noticing once these incubators, after a while, whenever they need components, something fails, they couldn't just get the spare parts, because sometimes they were donated by certain countries or by certain programs. And these spare parts were very expensive or very difficult to get. So at the time you have something fails, then the whole thing, you put it on the side, and they weren't able to use it. So they had a team of people thinking about how to solve the problem. And then they found out in this specific country that they had a very common car, which is the Toyota that I'm showing here, four-wheel drive. It was available everywhere. So they thought, why don't we create an incubator based on parts that are actually used in the car itself? And by that, actually, we'll have as many spare parts as we can. And that's exactly what they did. They created an incubator that was derived, and parts and spares became available. So it wasn't an issue anymore. It was very simple. Whenever something breaks, they go to the spares and replace it with no problem. This is an interesting story, actually. So the guy here on the right, he's an Argentinian mechanic. And one day he was at a dinner party with some people, and they were trying to open a wine, and the cork fell inside instead of going out. It broke and fell inside. So I guess they had so much wine, they started doing bets. So they said, okay, how can you get the cork out of the bottle without breaking it? So it started, somebody tried different things. And this guy here thought of an idea. He put a plastic bag inside. He kind of twisted the cork and inflated it and got the cork out. And won the bet, obviously. But then he went to his work and he started thinking, well, that's an interesting idea. How can I use it? And he had a friend who was a gynecologist. And they actually started thinking about ideas. And let me go here. And they noticed actually in Africa, in some poor countries, they didn't have enough equipment, and they were having issues with child being born. So they developed this technique to do suction of kids, and they were able to save so many kids' lives by doing this simple technique. So you can see just a car mechanic at a party developing something that's kind of been used in the gynecology field in different countries. And that tells you the progression of the thought and how things move forward. Dyson, it's an amazing example. So this Dyson actually is derived from the windmill saw that we see here. And so the windmill saw basically creates a cyclone, and the dust and the dirt sinks to the bottom, and the air goes a different direction. And they started working on that in the 70s, late 70s, and they created almost 5,000 prototypes until they got it right. And at the end, it's amazing what he's created. Because the problem with vacuum, it was a very simple thing, is the bag, whenever it gets filled, or even as soon as you start cleaning, the efficiency of the suction starts getting down because it's getting dirty and the filter is getting clogged. With this one, you don't have this problem because you always have amazing suction powers, and it's one of the best vacuums that you could ever see in the market. Obviously, it's expensive, but that tells you, how you can use technology used in different fields and apply it to completely different field and be able to solve a problem there. So I'll talk quickly about combining innovation. That's probably the simplest thing. You have two things and you want to combine a third product. That's the simplest way of doing innovation. So initially, in the 70s and 80s, where the regular bags didn't even have wheels, and then we started seeing bags with wheels. Now it's a standard to have a bag with wheel. And then I was traveling last week, and I saw a guy zooming by me, like, what the heck? So it's one of these little bags. It folds and becomes a scooter, actually. So it's amazing how they combine the scooter and a bag. So it's an amazing product, especially for airports that require long distances to walk between one terminal to another. This guy just folds it and zooms by it, and it's amazing, really. And that tells you the power of creativity and combining two things. Obviously, the smartphone and the watch created the smartwatch, and also let me see here. Yeah, so there's the way you open things. There is the soda can regularly and the bottle cap, and they combined both of them together. That you can open it like a soda can, but it has the cap of a bottle. And this is a cronut. It's a place in New York, actually. They combine the donut and the croissant, and supposedly, I never got a chance to try it, but supposedly it's an amazing pastry thing. So it's a cool thing. So let's talk about open innovation. I think that is something that we use so much at Johnson Space Center. It's been helping us tremendously. It's amazing what you can do. And it will be fascinating that most of the time the solution comes from different industry. It almost never comes from the same industry. Because, for any of us, if you've spent all your career in certain things, that's how you are trained to think about things. It's very difficult to look at it from a different perspective. You always need an outsider to look into it, to give you that different edge, different perspective of things. So let me give you an example about open innovation. So there was a study done by Harvard Business School about some nucleotide sequence that they had to do. So the first one, the first time they did it, they spent years and cost them millions of dollars to do the sequencing. And you can see the accuracy was almost 72% accurate, and it took them about 4.3 hours every time they wanted to do the sequencing. So they said, okay, that's long, we need to improve it. So they hired a group of two postdocs to work on that specific problem, and they paid them about $120,000 in salary, and they were able to make some progress. So they were able to reduce the time from 4.3 hours to about 47 minutes, and they also had an improvement in accuracy. But then when the open innovation started becoming popular, they said, okay, let's try this as an example, as a case study, to see how can we use advantage of the open innovation. So they sent that one in the open market, and they got so many solutions. If you look at the line there, it tells you below it is, above it, all solutions are better than the baseline. But if you look at one of the best solutions, so they went down from 4.3 hours to 16 seconds, and the whole thing cost them only $6,000. So that tells you the power available today and worldwide. So you can put a solution, and you'll have people from all over the world, from different backgrounds, kind of giving you answers for that. And by the way, there's a way you don't have to mention what the problem is specifically, because sometimes it's a competitive landscape, and all understand that. If you mention what the problem, people understand what your weaknesses are, and that will be bad for your business. But you can hide it in certain ways or break it into certain components. That's very difficult for people to see, first of all, what company is that, or see the big scheme if you break it into certain elements. So it's a very, very effective, and definitely we've been having significant successes with it. Design thinking, a lot of you guys know about design thinking. It's a user-centered approach, and it's an amazing process because typically engineers and designers and such things, they look at things and design them based on what they think the customer wants. So this system, this method, basically use the user, what the user wants, and have the direct dialogue. And it's composed of 5 different elements, and go through it. And sometimes you have to diverge and converge depending on what phase of the program. But I ran a workshop in January, and designing a wallet, basically, is a very, very simple example. So I had a fictitious customer, so I divided groups into 5, and had 4 people as designers and 1 person as a customer. So I told them, first of all, design this product for the customer without talking to the customer. And they whatever they thought was good, they designed something for them, for the customer, and they put it on the side. And then we went through the process and all the elements, and they designed the wallet based on the input and the interaction with the users. And at the end, they asked the customer, okay, how do you could you grade the system or the wallet before the system and after? And almost all of them give grades 3, 4%, 4 out of 10 in terms of satisfaction with the product, versus going after the design thinking, they were 9 or 10 out of 10 because they were involved in the process. And in Silicon Valley, people use it significantly as well. And you guys also have an amazing expertise in that field. I think it's definitely a good one. So I'll give some perspectives quickly about, like I said, what I've learned in the last 20 years, and we'll end up the presentation with that. So when it comes to innovation, there's 2 types of innovation. There's revolutionary innovation, and there's revolutionary or evolutionary innovation. Evolutionary is when you're increasing it by small amounts. Maybe you can improve it by 10%, by 20%. Revolutionary is when you maybe want to increase it by 1,000%. And to do that, you have to scratch everything and start from zero. And the thing is, it's very difficult to do, substantially complex, but if you produce something, most of the time it's a game changer. It could revolutionize a big portion of what you do by doing it that way. Innovation, we noticed that so much of innovative ideas always end up failing. And that's why it's not good to put all your eggs in one basket. You always have to diversify your portfolio of innovation, because the success rate is very, very small. But again, people still invest in it, and they put so much interest in it because the successes will have amazing inputs and amazing impacts on what you do in your industry, essentially. In terms of employees, there is 2 types of personalities that you've encountered in common companies. The farmers that typically want to have their own domain. They don't want to do anything else, don't want to be somebody interfering with them. They have their own thing. They do an excellent job at it. And then you have the hunters. The hunters are never going to stick with one project, always moving from one place to another, going here, jumping. I think to have a productive group, you need to have both working together synergistically. So you have the hunters going out, getting the ideas, getting the concepts, and then the farmers take it and develop it and make it something useful out of it. So I think it's a critical, delicate balance between both of them. And you can achieve that one, the efficiency of the organization will be substantially better. When you're working on products, obviously there's always going to be teams working on products, not a single person. It's very important that you make people feel that everybody's input is appreciated and being used. Obviously, you can as managers, you can force somebody to do work or attach to a certain project. But imagine if you convince people that this is what they need to do because they're part of it. So that's the difference between management and leadership. You need to use an element of leadership to enable people to look at it differently. So if people think, hey, this is part of my ideas, this is my project, the passion, the energy will be completely different than if you were forced to do something because this is what we're working on. So there is classes and things you can do to start modifying it, but it makes big difference actually. In ideation, obviously it's very important to have a very diverse team of all aspects, ages, technical aspects, cultural aspects, and then also concentrate on quality and quantity initially versus quality. So the more ideas you have, the better. You can also do leapfrogging, so combine 2 ideas into a third idea and move forward like this. And it's very important that you always say yes and. If you say no or no but or yes but, then you start killing creativity. And it's a very sensitive phase because, for example, we have a group of 10 people, and you start to come up with an idea, no, that's not going to work. And this guy comes up with another idea, no, that's not going to work. The whole energy of that group goes down. So you always, in that phase, you have to keep saying, yes, it's a good idea, write it down. And there is obviously phases that you go through it, and you classify them into what's good, what's not, and choose the best one that you have. We hear this a lot, especially in the space industry. Failure is not an option. And actually, failure is an option. It's encouraged, actually. It's an excellent option. That's how you learn how to do things. Now, there's a difference between failing in a lab environment and failing when you have a rocket ready for launch with humans in it. That's absolutely not an option, right? So it's a very big difference that people need to understand the thing. And some companies, they appreciate that. They have some awards for the people that failed certain ways, and that tells you how much important and how much value you learn from failing to be able to improve what you do. This is one of the most killers to innovation. Well, nothing wrong with it. Why should I mess with it? Well, if that was the case, then we'll be driving horses to work. Everybody has a cart with a horse. Nothing was wrong with that. And you always got to keep moving. You always got to keep improving. It's not enough that you have something that's not, it's working to say, okay, it's working. Always have to keep looking at it, especially in today's environment where technology is increasing so much. You have so much competition. So if something is working, then make it better. And next year, make it even better than this year. Capitalize on what's being produced, what technologies we have in the market, what research they have on, and keep improving it until it's a continuous process. So that's we're talking about that earlier, is benchmark from outside of the industry. So we've been working with so many industries outside of the aerospace, and people initially were kind of surprised. Why? For example, we're working with oil and gas a lot, and they didn't see what the applicability, what the commonality between oil and gas and space. But if you look at it, it's both of us work in remote environment, in extreme environment, in difficult access places. And the technologies are very similar that we need in terms of instrumentation, high temperature, and simulations, materials, robotics. So just the end use is different, but the technology itself is very common. So it's very good to keep benchmarking and going, visiting other companies, seeing what they do, how they do it, and form partnerships. You always have to take risk. If you don't take risk, you're not going to do anything. Obviously, it has to be measured risk, but risk is always a good component of moving forward. And that's a quote by the CEO of BMW. When he decided to invest in the electric car, people were against him, and he said, no, that's definitely something we need to do, because doing nothing is actually a much bigger risk than spending the resource and investing in that. So taking risk is always good, as long as it's measured risk, because that's how you move forward. Without risk, for example, for us, we'd never launch a vehicle. We'll always be on the ground. So there's always some calculated risk that needs to be taken in place. I had the conference about a few months ago, and I have the president of Toyota actually as part of the conference, and he shared this quote with us. So the Prius, which is one of the amazing cars that Toyota has, surprisingly, most of the executives were against it. Nobody wanted to invest and do it. And at the end, we know it's one of the most successful cars Toyota has ever produced. And that tells you sometimes the misalignment between the top executives, the working force, the market, and even for a company like this, so it's fascinating how we need to increase have the similar visions as compared to complete disconnect between the employees and the executives and so on. So innovation and research and development is one of the things that get cast the first thing when your business is struggling or when there's financial issues. The first thing people look at, research and development, innovation go down. And unfortunately, that is the time to invest in these kind of things, because that's going to, for example, the oil and gas industry went through its big impact a few years ago. And the people that continued investing in innovation and research and development, right, when it's time to start getting out of that ditch and start being productive again, they had technologies that were creative, and they're going to have substantial advantage versus people that decided to cut research and development and their creative programs and so on. So it's always important to do that. And a lot of actually organizations, they create shelters. They have their organization in charge of innovation. They put them out in different locations, and they kind of try their best to shelter them from the common areas. So I go a lot to Google, and we benchmark a lot. And one of the things I like to do is see what other people are doing. How can we learn from each other? And because there is substantial value in doing this. So one of the nice quotes that I hear from them is, you cannot force innovation, right? But you can create an environment in which innovation can take place. And you can see that first time when you walk to the main Google campus. You go there, immediately you feel different. Everything is so creative, the desks, the way people work, the culture itself. It's a fascinating place. And then the governance itself, how everybody shares the calendar with each other. So if you have a project, I've seen, for example, people work on similar projects and without knowing about it in organizations. So what they do is they share everybody's calendar. If somebody's interested in doing a new project, they can actually have access to see if somebody else is doing something similar in a different department and start working with them. And then the culture itself is so open that the CEO actually every Friday spends about an hour. They call it Thank Google, It's Friday. And he answers almost every single question that employees has. He talks about the failures, by the way, also a lot. Not only the successes, but what failures did we had? How can we learn from this? And people find the culture itself very, very, very creative. So I've noticed this a lot as well in my organization is employees sometimes come with amazing innovative ideas in terms of technology, but the problem is people in the middle management. And even if the executives actually say, we need to be more creative, we need to create this, and it always stops in the middle management, because innovation takes risk. And people are not comfortable taking risks. So you have to force them actually to go out of the comfort zone to be able to make some progress in this year. So maybe some of the things we tried doing is maybe putting it in the performance evaluation, that you are supposed to create something or do something in that realm in terms of innovation. Because otherwise, people, it's very, very difficult to take risk and move out of the comfort zone. So organizations sometimes need to be careful as well when people coming up with ideas. If an employee comes to you with an idea and he said, no, what are you talking about? This is never going to work. You come up with another time, you lost this person. He's never going to come to you again. But we can learn actually from kids. Kids will come up with a ridiculous drawing. And this is a drawing by my daughter when she was 4, and you can see the handsome guy on the right is supposed to be me here. But the thing is, a kid will never be shy to share a drawing like this with you, and they're proud of it, right? And that's the thing we need to create in organizations. And by the way, if I show you a drawing, I didn't have access to some of her drawing because it's in Houston. It's fascinating what she draws right now. But if early on I said, no, this is stupid, this doesn't look good, that's it. She would have probably lost interest in that thing. So it's very, very essential how do you treat your employees and make sure you don't encourage them. Even if you have a thought that's not that good, maybe you can guide them, but always be positive in the way you deal with employees, because that has long-term impact on them. Also, the environment itself. Even yesterday, we were at ESTEC in Netherlands, and that's an example I saw in a lot of the meetings that I had. We were in a conference room in a very formal setting, and the meeting is just very formal. You don't have something creative. And then one time we took a break, and it was one of these companies that they have their own cappuccino machines. They have a whole set of coffee equipment. And we started talking there, having discussions. They had boards. It's like I felt I was at a different company with a different group completely. Just by changing the setting from a formal conference room, going there, it became 100% different. And it's just fascinating, the change, how severe it's changed from where we were before. And this is what I talked about earlier, is never anchor yourself in today's technology. So when people come and want to invest in something that, or start developing, put resources into technologies that are existing today just to make it better, I don't like that. I typically like to say, okay, think about, if you're working on something, how can you be the best of the best? If somebody goes and do a search, who's going to come on the top? And these are the things that you need to invest in terms of innovation I'm talking about, not obviously a normal thing. But if you're trying to be innovative, you need to invest in something that can be mainstream in the future, not now. So by the time it becomes mainstream, you're going to be the top. You're going to be the world leader and authority in that field. And that's going to give you significant advantage moving forward. So we've been working a lot with academia, with industry, with other government labs. Because like I said, it's very important to capitalize on the resources from other people. So you'll use the same product, you get different perspectives, you get much less financial resources, you have amazing ideas, and together you come up with projects and that's much better than what you do. So imagine if you find strategic alliances and you start working on them, and working on common problems that will benefit everybody. I think it will be tremendous implications, and everybody will be significantly more successful in what they do, for sure. So with that, I conclude my presentation, and thanks for your time coming this afternoon to listen to it. If anyone has some questions, we can take a few questions.
I always ask questions.
Yeah.
So you started with a ambitious view for the world, and also mentioned that there's a split between half of scientists are excited and see the great opportunity, and the other half are concerned. And I guess, if you think about it, really, the big issue isn't actually science and technology. It's actually more of a societal, a political issue.
Sure.
And what we're seeing happening in the world today is, obviously, we've got populism, we've got, these extreme attitude, we've got a fear of science and technology.
Sure.
And I guess my question to you is if we are going to be successful, if we're going to build a world that's that world we all want to live in, or we want our children to live in,
right,
the science and technology community need to be collaborating and engage more with the political side of the house. And today, that's not really happening. You see science lobbying for its own interests,
absolutely,
but not actually. So everything from universal minimum wage to net neutrality to data protection, these are all topics that are actually not really being discussed in a way. So I'm just worried that, so what do you think we as technology people and scientists need to do to work with governments and agencies to create the environment that allows technology to be positive and not negative? Yeah,
no, that's exactly right. You have an extremely valid point. And the thing what we can do is obviously start outreaching, showing people, because sometimes the politicians or the decision makers, they need people like scientists and engineers and big executives to show them what the future is looking like, and how can we start looking at it and investing today. So in this case, like we said, we're talking about almost creating a new species. So people were concerned about the Industrial Revolution. Well, that's going to be the end of jobs, but we found out it wasn't the case. It obviously took a chunk, but people readapted and got jobs somewhere else. But here, when you're creating almost, like what some people call different species, is it could compete with you in every single element, and that's very dangerous in terms of huge population increase and technology. So we're talking about what is the economy. The whole economy might be different, actually. We're talking about creating even economists need to be involved in that. So if people don't have jobs and machines and equipment, and artificial intelligence can do a lot of things, so what does that mean, right? What is that future economy going to look like? That things definitely needs to be discussed.
What is currency?
Right, and people, I don't see a lot of people discussing it as much. Just every now and then you hear a headline about something, but it's a topic I believe we should definitely spend more emphasis and resources in discussing it and creating possible alternatives as we move forward.
Any other questions?
Thank you. A question on how you see IBM or even large multinationals engaging in open open innovation. You look around this room, we've got a lot of intelligent people here, young people, vibrant.
Yeah.
How can you, what do you think the challenges are for a company like IBM to engage in open innovation?
Yeah. No, IBM is obviously is one of the world-leading companies in the field. The Watson computer is world-known everywhere now. It's like an authority in the field. I personally, like I said, what I've seen the resistance to open innovation is people are afraid to share their challenges, because that opens up a whole door to competition, seeing what you're doing. So as I mentioned, definitely, and companies, by the way, in that field, they understand that, and they're trying to come up with methods and tools to mitigate that. So for example, it's more anonymous, the way you do it, and it breaks it down into some sub elements that it's very, very difficult for anybody to understand what your issue is. I think, in my opinion, this is what was one of the biggest issues that companies were resistant into implementing it. Because in terms of cost, it's negligible, and in terms of value, it was substantial. So if you can actually pass this hurdle and this roadblock about advertising what your challenges and gaps, I think that will go a long way into being more implemented in different industries.
Thank you.
I'm not sure I want to trust my rugby skills that far.
Yeah.
I think we'll just stop there just in terms of time. On behalf of IBM, we'd like to thank Omar. I think a fascinating presentation, very relevant to IBM, very relevant in terms of us with innovation as well. We have tried some of the stuff with Top Coder as IBM, so we have, but it does get into what do you put out there and what are you willing to share as well. But on behalf of IBM, thank you very much. Fascinating and
thank you very much.
Great pleasure having you.
Thanks for having me.